In this video, I want to give the basic set laws, do some examples of using sets, and then show how to display sets using Venn diagrams. The first set of laws I want to look at are the associative laws. A union B, union C, is the same thing as A union B union C. And the same thing with the intersection. If I want to either take the union or the intersection of three sets, I can move the parentheses around appropriately. Next, we have our distributive laws, which is how we can combine unions and intersections. A union B intersects C is the same thing as taking the intersection of A and C, the intersection of B and C, and then the union of those two sets. We also have the A intersect B, union C, is the same thing as taking the intersection of the sets A union C, B union C. Finally, we have De Morgan's laws. The complement of A union B is A complement intersect B complement, or the complement of A intersect B is A complement union B complement. So if I want to distribute the complement, I need to switch intersections to unions and unions to intersections. Now that we have the idea of the set laws, let's look at some examples of actually using sets. Let's suppose we have a random sample of 100 cell phone users, and their next phone call is categorized according to its duration and the number of handovers it undergoes. So here I have a table. The top row tells me the number of handovers. The first column gives me an idea of the duration, and then I have the number that matches up with each of these. We're going to let A and B denote the events that a phone call undergoes one handover and a phone call lasts less than 3 minutes, respectively. So A is the event that a phone call undergoes one handover, which would be this column right here. B is the event that the call lasts less than 3 minutes. So that would be the bottom row right here. I want to know how many calls belong to A union B. Well, in this case, I would just need to add up all of my shaded areas. 20 plus 40 plus 15 plus 5, which would be 80. So there are a total of 80 calls in A union B. What about in A intersect B? A intersect B would be what they have in common, what they share, the thing that's shaded both colors. In this case, 15. Next, I want to think about A union B complement and what this means. Well, we know A union B is all this stuff highlighted, so A union B complement would be the stuff that's not highlighted. So this would mean that it needs to be greater than 3 minutes and either 0 or more than one handover. Next, I want to think about A complement intersect B complement. According to De Morgan's law, this should be exactly the same as what we just were talking about, A union B complement. But let's see if this makes sense. A indicated that it went one handover, so A complement, it would need to go either 0 or more than one handover. B complement, well, B said that it was less than 3 minutes, so the opposite of that would be greater than 3 minutes. And I want to take the intersection of these two, so I needed to satisfy not only one, but both of them. So I needed to have either 0 or more than one handover and have more than 3 minutes long. So this is exactly what we had talked about before, so this kind of helps us see that De Morgan's laws actually do make sense.